All right, this is lesson 1.3 in our Intro to Math 1 video notes. We're going to be talking about the greatest common factor and least common multiple word problems. A lot of people get a little nervous when they see word problems, but I'm hoping that after this video, you feel a little more confident. In the section where it says, how do I know what information to use? These are the first two steps in a word problem strategy that I would recommend you use every time you see a word problem. So let's go ahead and try it here. We're going to underline the important information, and then we'll circle the question. It says that Luca is baking cookies to put in packages for a fundraiser. Luca has made 86 chocolate chip cookies and 42 sugar cookies. That's important. So they're both talking about cookies, but they're talking about different types of cookies. You don't have to, but you could color code it as you're underlining. I'm going to use blue for chocolate chip cookies and red for sugar cookies. Continuing on, it says that Luca wants to create identical packages of cookies to sell. That's important. They need to be identical packages. So if it has, one chocolate chip cookie in each package, then the next package also has to have one chocolate chip cookie. You can't have different numbers. Oh, that should say he. He must use all the cookies. So we're looking for numbers that go into 86 and 42 evenly. Circle the question. What is the greatest number of identical packages that Luca can make? All right. So, hopefully, as we're reading about this, we're thinking, okay, I have 86 chocolate chip cookies. I can put, one cookie in 86 different packages. Or I could put two cookies in, what would that be, 43 packages. Essentially, what we're doing is we're looking at the factors of 86. So if we take those 86 chocolate chip cookies, I could have one bag of 86 cookies, or you could think of it as 86 bags, each with one cookie in it. Another way to factor 86, remember when we're listing all the factors, we just go in order. After starting with 1, we check 2. And since 86 is even, 2 is definitely a factor. It's going to be 2 times 43. Check the next integer, that would be 3. But however you want to check, either mentally or with a calculator, 3 does not go into 86 evenly. So we're going to get rid of that. In fact, 4 doesn't go in 86 evenly either, or 5 or 6 or 7. We could keep going down the list. We are actually done. So the only factors of 86 are 1, 2, 43. Remember, we reviewed prime numbers the other day, and 43 is one of those prime numbers. That's kind of how you can tell that's a prime and that's a prime. There's not going to be any other factors. And then 86. All right. Let's try the same thing with the sugar cookies, though, because each package is going to have a certain number of chocolate chip cookies and possibly a different number of sugar cookies. So there were 42 sugar cookies. Again, if we factor that, that could be 1 times 42. Could 2 go into 42 evenly? Yes, it could be 2 times 21. Does 3 go into 42? Well, remember, the shortcut for divisibility by 3 is adding the digits. 4 plus 2 in number 42. 4 plus 2 is 6, and that's a multiple of 3. So is 42. 42 is actually going to be 3 times 14. And then, does 4 go into 42 evenly? No, it does not. 5 doesn't either, but 6 does. 6 times 7 is 42. And then after that, you're done, because the next integer to check would be 7, but it's already in our list there, so we don't need this 7. So the factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. All right, and so since we're looking for the greatest number of identical packages that Luca can make, we're looking for the greatest common factor, or the biggest number in both of these lists here, and that turns out to be the number 2. 43 is bigger in the blue list, but there is no 43 in the red list. There's also no 86 in the red list. And then all these numbers here, 3, 6, 7, 14, 21, 42, those are bigger than 2, but they're not in the blue list. So the greatest common factor of 86 and 42 is 2. But we need to answer our question that we circled. That's why we circle it, so we can go back and make sure we answered it. Luca can make, we could say at most, 2 identical packages. So he could either just make 1 package with 86 chocolate chip cookies and 42 sugar cookies, or if he wants to make the most packages, he could make 2 packages, and each package would have 43 chocolate chip cookies and 21 sugar cookies. All right, so these notes only covered a greatest common factor word problem. You can tell that this word problem is talking about the greatest common factor because we're talking about factors of the 2 given numbers. When you have that 86 and the 42 that are given, we're not counting multiples of those numbers. We're looking at numbers that go into it. A lot of times they'll be worded where they give you a total, like 86 chocolate chip cookies, and ask you to make equal groups, which is exactly what we did here with identical packages. In contrast, least common multiple type word problems are talking about the multiples of two given numbers. A lot of times they'll say like, hey, this happens every 3 days and something else happens every 5 days. When will they both happen at the same time, or something like that? So let's do one of those together. Do me a favor, pause the video, and I want you to tell me, of these 2 questions, of these 2 word problems, which one is a least common multiple word problem? Okay, hopefully you recognize that number 2 is a least common multiple word problem. Let's do it together. 2 neon signs are turned. Oh, you know what, let me go ahead and erase this part. Number 1 is actually just like the last page. That one's a greatest common factor problem, but we did one of those already, so you can do that one on your own. Here we go. Number 2, 2 neon signs are turned on at the same time. Both signs blink as they are turned on, and then it says one sign blinks every 9 seconds, the other sign blinks every 15 seconds, and how many seconds will they blink together again? So let's start with the first sign. It blinks when it's turned on, and then 9 seconds later it will blink again. And then 9 seconds after that, it'll blink again. So 9 times 2 is 18. So in 18 seconds after it was turned on, it'll blink. 9 seconds after that, it'll blink again. So that's 27 seconds after it was turned on. And then 36 seconds, 45 seconds, 54 seconds, 63 seconds. I'm just listing out the multiples of 9 to show when that first sign will blink. What about the second sign? Well, it blinks every 15 seconds. So it turns on and blinks at like 0 seconds, and then after 15 seconds it'll blink. And then if I add 15 seconds to that, that'd be 30 seconds after it was turned on, it'll blink. And then 45, and then 60, and then 75, and so on. Now, it's asking in how many seconds will they blink together again? In other words, what's the least common multiple, or the smallest number that's in both the blue list and the red list? Take a moment, see if you can find it. What's the smallest number in both lists? The smallest number is 45, because these blue numbers are smaller than 45, but none of them are in the red list. And these red numbers, 15 and 30, are smaller than 45, but they're not in the blue list. So we found the least common multiple of 9 and 15 is 45, but we need to answer our word problem in how many seconds will they blink together again. The signs will blink together after 45 seconds. There we go. As always, ask a question about something you saw in the video or make up a practice problem. You can make up a word problem. It doesn't matter if it's a GCF or LCM problem. And I will see you all in class.